A very large ohms value, is it the same thing as an open switch? Does an open switch have infinite resistance? And am I talking about resistance here? So, in this circuit, if I don't have my signal, then if I have only the circuit, basic circuit with a DC voltage, then this is open, and this is open. So am I just left with the voltage divider circuit? So with DC analysis, I don't have to worry about the AC signal here. I don't have to worry about the capacitors here because they're open. Now let's take the second case. AC. Let's say the frequency is 10,000 hertz. Okay? And the capacitor is 100 microfarads. So I've got 100 microfarads, 100 microfarads, 100 microfarads. Or even 10 microfarads, 10 microfarads, and 10 microfarads. It's okay. And a frequency of 10,000 is approximately what we can hear. For music, we're talking about 1,000 hertz, 2,000 hertz, 5,000 hertz, 10,000 hertz. If you're young, like I'm old, so I cannot listen to a lot of high frequencies, right? But you guys can probably listen to 25,000 hertz, whereas I can stop at maybe 10,000 hertz. Okay, so now let's calculate and see. 1 over 2 times pi times 10,000 times 100. If you do this calculation, what do you get? 159 milliohms, or 0.16 ohms, right? That's it. So look what happened. From no frequency, where the capacitor acted like an open, to a reasonable frequency, 10,000 hertz, the capacitor acts like, what kind of a resistance is less than 1 ohm? Basically a closed switch, right? When I close the switch, what's the resistance across a closed switch? 0, right? 0.16 ohm. Is that a large resistance? No. So the capacitors act like a closed switch. So here's my little signal here coming at about 10,000 hertz. This capacitor is going to act like a closed switch. This capacitor is going to act like a closed switch. This capacitor is going to act like a closed switch. When this capacitor acts like a closed switch, what's going to happen to this resistance here? Is it being bypassed? Is my signal now tied to ground here? Right? 0 ohms here, 100 ohms here. This is not going to be seen, right? This is shorted. Basically, this point emitter is shorted to ground. So that's what's happening. That's why we call it a bypass capacitor. We're bypassing RE. Okay? Good. So that's why the bypass capacitor note at the bottom of page 5 shows, in the middle, it shows for a DC voltage, it's like an open switch. With an AC signal, that capacitor is going to act like a closed switch. Okay? Good. Now, we're going to go to page 6, but before I go to and talk about page 6, I'm going to start my calculations on page 7. And I have to do two analyses to this circuit. I'm going to do a DC analysis, and I'm going to do an AC analysis. So for the AC analysis, I'm going to come back to page 6, but first let's do the DC analysis for the circuit of page 7. So let's now all go to page 7, get your pen or pencil out, and do the DC analysis, which is the voltage divider circuit. So, first thing is draw your load line. X-axis, VCE. Y-axis, IC, 0. First calculation or information, cutoff. Cutoff means what? Cutoff. Cutoff means open switch, right? The transistor is going to act like an open switch. So that's what I'm going to show. Voltage or current is 0. So cutoff, draw a symbol like this. Open switch. So VCE will be VCC, which is how much? VCC in this circuit, 15 volts. Where do I show the 15 volts? Right here. We have done this many times, right? That's the cutoff point. Saturation point. Saturation means the transistor is going to act like a closed switch. So, the current, IC sat, is, if this point is going to act like a closed switch, then of that, VCC, RC, and RE. RE in this circuit is made up of two resistors, RE1 and RE2. So both of them together is RE. So can you do that? Can you show this? Right now it's like this, right? RE1, RE2. Can you do this and say RE? So, is that VCC over RC plus RE? Are you with me? So is that 15 over, how much is RC? 12K. How much is RE, which is RE1 plus RE2? Is it 100 plus 2.1K? 2.2K? How much does it work out to? What is 15 over 12K plus 2.2K? How much? 1.06 million. Where do I show the 1.06 milliamps on the graph? Right here. Saturation.